We'll take a look at the law of cosines in this video. So sometimes the law of sines doesn't work in order to start solving some of these problems. So for example, you look, this is page 7 in your notes. If you look here at this first example, we want to find the length of AC. So if all of a sudden we circle x and 109, well, the problem is we don't have an angle in C or A to match up with this 28 or the 26. So we're going to need another way to solve this. And that's where the law of cosines comes in. So what the law of cosines is going to do, if we label this triangle A, B, and C, remember uh, little side A is across from angle A, and across from angle B is little b, and then across from angle C is side C. And so the way the law of cosines works for sides, I've always done it blank squared equals blank squared plus blank squared minus 2 blank blank cosine of blank. Now, seems a little overwhelming at first, but again, what we're going to do, what goes into these blanks is determined by which angle we want to deal with. So let's say, for example, we want to do angle A. So the angle will always go with the trig function. Right? You're always going to put your angle there. And then you go, what is across from A? Well, across from A is little a. Well, that goes across the equation, so it would drop into this side of the equation. And now we've got these blanks that are squared and these other two sides, or these other two blanks. And what's going to go into there are the two sides B and C. So you'll just put BC, BC. You could also play this thing out. So blank squared equals blank squared plus blank squared minus 2 blank blank cosine of blank if you wanted to find angle B. So if we're talking about angle B, what's across from angle B? Well, that's side B. So you'd put side B here. And then the other two sides will go in the other blanks. So you just drop AC, AC, and you follow that pattern. You alternate them. And you could have done CA, CA, as long as you get some kind of pattern where you don't do AA or CC. And then finally, we could also solve this thing for angle C. And so if you put big C here, what's across from big C? Well, that's little c. And then A and B, A and B will drop into there, right? So we'll try this with number 1 here. What you'll do, right, we'll do our blank squared equals blank squared plus blank squared minus 2 blank blank cosine of blank. Go ahead and find that angle. The angle that we circled is 109, so you put 109 in the blank. What is across from the 109? Well, that's what we've circled. That's x. And then what are the other two side lengths? 26 and 28. So you'll put 26, 28, 26, and 28. And I'm going to put parentheses around those just to remind us that we need to multiply. So at this point, you can literally type in this entire piece into the calculator all at once. So I'll go to the calculator. I'll do 26 squared plus 28 squared minus 2 times 26 times 28 times the cosine of 109. Again, making sure we're in degree mode. And so x squared is 1934.03. One more step. Take the square root. So here x equals 43.98. Right? Here we'll go down to number 3 just so I have a little bit more room to work. Find AB. So there's your x. So go ahead, just like we do with law of sines, circle the ones across from each other. So we're using law of cosines here. So blank squared equals blank squared plus blank squared, excuse me, minus 2 blank blank cosine blank. So the angle, 129, will go with cosine. The angle will always go with the trig function. And then what's across from it goes to the other side of the equation. And that leaves us 27, 24, 27, 24. I'll put the parentheses around. And so it's literally at this point, you just go straight to the calculator, type all of this in. So the toughest part about law of cosines is just making sure you set it up correctly. So here we go. So 27 squared plus 24 squared minus 2 times 27 times 24 times the cosine of 129. So x squared here is 2120.6. Don't forget to take that square root. So here x equals 46. We'll just go 46. Right. Now, if you turn the page, all of a sudden now we can be asked to find an angle. right? Which is a little bit different, right? Find angle C, find angle A. And if we're going to start setting up our law of cosines, it becomes a little bit trickier with angles. So if I take a look at this example, actually on the homework page, over on page, I believe this is 9. Yes, page 9. We'll look at example 1 and 2 here. So 1, again, circle there, blank squared equals blank squared, plus blank squared minus 2 blank blank, cosine of blank. So your setup, 114, x is across from it, so 17, 28, 17 and 28, and then you know where to go from there. And if we look at number 2, it's a little bit different if we find measure of angle A. So now all of a sudden when you do your law of cosines, excuse me, blank squared equals blank squared plus blank squared minus 2 blank blank cosine of blank, now all of a sudden the angle, right, x is your angle, x is now over here with cosine. And we can go ahead and put, right, there's 6, it's across from it, and then your other two sides, 6 and 5, 6, 5, 6, 5. The issue here is that x is over here in the angle. So what we can do, if you'll actually go back, maybe I'll give myself a little bit of room here. What we can do to solve for angles is there's a formula we can use. We're going to do cosine inverse, and in the numerator you're going to do a squared plus b squared minus c squared over 2ab. And really all this is just you've just moved around some of the pieces from here. Here's the one trick to this though. C is always across from the missing angle for us in this scenario. So I'll clean up the box a little bit. So at the end of the day, this is what we want in our box. Maybe these two formulas right here. So to use this angle formula, remember, oh, excuse me, remember that the C in the formula, so for the angles, this C is always the side across from the missing angle. So let's go back to that problem. So we'll go cosine inverse. So that means here's C, and we'll just call these A and B. So a squared, 6 squared, plus b squared, plus 5 squared, minus 6 squared, over 2 times 6 times 5. And I would suggest doing this one step at a time. Let's do the whole numerator first. So 6 squared plus 5 squared minus 6 squared, put that in the calculator, it's 25. And then 2 times 6 times 5 is 60. And now I would type into the calculator second cosine, 25 over 60, which is 65.38, which makes a lot of sense. 65-degree angle in a triangle.